Welcome on. This is the paper discussion that which is held recently from Myrank. This paper is conducted on 13th July recently. So this is the physics paper discussion, students. Physics paper discussion. These questions are given from 101. As you see this question, the object in figure weighs 100 kg and hangs at rest. Then T1 by T2 is. You see this object 100 kg object is hanged. It is suspended, students. This 100 kg body is suspended using the strings. Here you see the strings. The T1 is connected to one side of the wall, and top side you can see another string is connected, and the tensions are acting like T1 and T2 are making angles 37 and 53 degrees. Okay, as shown in the diagram, right? So he's saying that this 100 kg body is at rest, students. The rest condition, what we can say, so equilibrium condition we can consider here. So this T1 makes angle 37 with the horizontal, T2 is making 53. So we can write like this. Since this is at rest condition, what we can say? So T1 cos 37. See, this is angle 37, students here. So T1 cos 37 degrees equals to T2 cos 53. T2 cos 53 degrees. This is 53 degrees because it is a rest, right? It is under equilibrium condition, I guess. Equilibrium. In this case, we can write like this. So it's asking to find T1 by T2. We have to answer for T1 by T2. So T1 cos 37. What's the value of 37? You see here, right? Suppose if you're taking this as 37 degrees, since you have to remember cos 37 as 3 by 5, so opposite by hypotenuse, obviously this becomes 4. So now cos 37, T1 is T1 only, cos 37, cos means adjacent by hypotenuse, adjacent is 4, hypotenuse is 5, so therefore 4 by 5 is equals to T2 cos 53. If it is 37, obviously this will be 90, students, this will be 53 degrees. So cos 53 adjacent by hypotenuse means 3 by 5. So 5 gets cancelled here, right? This 5 gets cancelled, and your T1 by T2 is resulting as 3 by 4. So this is the answer. See here, it is the answer. Option 2 is the correct one, right? And the second question is this. An adiabatic cylinder has 8 grams of helium in it at 400 kelvins, and its a piston of area 1 centimeter square, which has mass 1 kg, is mobile. See, friends, this is the piston. This is called piston. This is mobile, right? It can be moved. A block of mass 62 kg is placed. So on this, one block is placed, friends. On this piston, one block is placed. One block is placed like this, right? Now, the situation, right? Like this, it is there actually. It is there like this. Here is the gas. It is gas, friends. Now, a block of mass 62 kg is placed on the piston, then the final temperature of the gas will be take atmospheric pressure as 10 power 5 Newton per meter square and G as 10 meter per second square. So it is obvious, friends, atmospheric pressure always will take it as 10 power 5 Newton per meter square or pascals, which is the unit of pressure. So let me write all the values here. Mass, first mass is given. What is the mass? 8 grams. Cylinder. Inside the cylinder, helium is there, students. So this is nothing but mass of the helium given as 8 grams, students. This of 8 grams. And next, the M2 is given as 1 kg. Of course, it is a cylinder, right? Cylinder mass. And the initial temperature is given as 400 kelvins now. Yes, 400 kelvins. This of 400 kelvins. And next, area of the piston, students. it's given as 1 centimeter square. See here, this is the area of the piston, 1 centimeter square. So like this it's given. Now finally what is asking for us? Right? Temperature T2. Then final temperature, this means T2 is asking students, T2 for T2 is asking. T1 is given as 400 K. M1 given as 8 gram. M2 given as 1 kg, right? Where this block mass is 62 kg. We'll see. For this also we'll see. Now first we have to find for temperature now. So students, here is saying that adiabatic process. Okay, adiabatic process. Adiabatic cylinder means gas is under adiabatic condition, where adiabatic condition is that change in heat energy equals to 0. So students, in adiabatic condition, in this adiabatic condition, I can write like this, friends. In this adiabatic condition, relation between T and P, because he mentioned about temperatures and pressures. I can say that T power gamma by P power gamma minus 1 is equals to T power. It is nothing but constant. It's nothing but constant. So here in this case, I can say that T1 power gamma by P1 power gamma minus 1 is equals to T2 power gamma divides by P2 power gamma minus 1. This holds good. Right? Now, what is P1 and what is P2? That's the next question. What is this P1 and what is this P2? That's the next question we have. So for that, I can say that P1 is nothing but atmospheric pressure plus the force by A, F by A, because masses are placed, students, there. Okay, piston mass is there and block mass is there, right? So that's why in case of this piston, if I say pressure as P1, in case of this one massive block, 62 kg block is placed in a, so for that I can say P2 as P0 plus F by A again. What can you write for this F? P0 is P0 atmospheric pressure, students. F means mg by A. Mass given, say this as a small m, otherwise G value 10 if it is mentioned. Yes, it is mentioned 10, otherwise 9.8 only. So let me simplify for this. P0 means atmospheric pressure according to the given 10 power 5. And this is M1 is 1, students, here. M1 means here, you see in this assumption. Here, yes. Here this is mass of this only, students. Mass of helium is 8 gram. Right? Let me correct this one. Mass of helium as 8 gram. And M1 is 1 kg. Right? And whereas M2 is 62 kg now, isn't it? 62 kg block is placed like that, he told. Yes, likewise, this is taken as M2 now. This is mass of helium. Now you see, in this case, 10 power 5 plus mass is, okay, 1 kg. G value is 10 now. Area is nothing but 10 power minus 2 whole square, students. 10 power minus 2 whole square means 10 power minus 4. So this results 10 power 5 plus, okay, 10 by 10 power minus 4, I can say. Right? So that means 10 power 5 plus 10 power 5, students, which means 2 into 10 power 5 pascals. This is the value of P1. Due to M1, students, this is of M1, right? Likewise, P2, for P2 we have to answer. So therefore P2 is nothing but P0 won't changes, it's 10 power 5 only, plus mg Mass how much, students? Now M, how much you have to take? 63 you should take, students, because 62 plus 1. 62 kg is the block mass and 1 kg is the piston mass is there. So G value is 10, students. By area will be the same, 10 power minus 4. So altogether 10 power 5 plus 63 into 10 power 5. So you can say that this 1 into 10 power 5 and 63 into 10 power 5. So 64 into 10 power 5 pascals, right? So now these values we are substituting. T1 given as 400 power gamma by P1 is how much, students? P1 comes like 2 into 10 power 5, 2 into 10 power 5, right? Gamma minus 1. Here I can write the gamma values here only. Here a helium, so it should be helium. Monatomic, no, students? Yes, monatomic. So 400 monatomic means 5 by 3. So this are 5 by 3 minus 1. Isn't it? So T2 power 5. Okay, gamma is 5 by 3. Here it's of P2 is 64 into 10 power 5 whole power. This is P2 value, students. So whole power 5 by 3 minus 1 means how much it is? It's of 2 by 3, no? Yes, 2 by 3. Here it is 2 by 3 again. So solving this, we can get answer as 1600 Kelvin, students. Just simplification of, right? Like this. So therefore your option 4 is correct. Option 4 is correct. And this. So the next will go. To establish an instantaneous displacement current of 2 amperes in the space between two parallel plates of 1 microfarad capacitor, the potential difference across the capacitor plates will have to be changed at the rate of. So, students, it is related to the displacement current. Displacement current equation, what we have? Displacement current. Displacement current. Okay. Yes, displacement current, what we have? So displacement current ID is nothing but epsilon naught into d pi by dt. This is the equation for displacement current, isn't it? This is the equation for displacement current. This is given as 2 amperes now. So now is asking to find rate of, okay, you see this, the potential difference across the capacitor plates will have to be changed at the rate of, which means dV by dt is asking, students. Rate of potential is asking for us. Of course, parallel plates, okay, capacitance they mentioned as 1 microfarad, right? So let us discuss on this. dV by dt we should get. So therefore, students, ID is nothing but epsilon naught. This d pi by dt, pi is nothing but e into a. So let me write d by dt of pi is nothing but e into a, electric field into area. So now we have epsilon naught e, okay, into a, right? So this d by dt, okay, e can be written as v by d, students. From v is equals to d relation. So that is displacement current totally. So now you see, one side we can get this value dV by dt now. So this dV by dt, now you see epsilon naught E by d into dV by dt is displacement current. So therefore, dV by dt is nothing but displacement current by this total value can be written as capacitance, students, isn't it? So therefore, because they mentioned for capacitance there, so displacement current is 2 amperes and this capacitance given as 1 micro they given, yes, 1 microfarad. So therefore, this results 2 into 10 power 6. 2 into 10 power 6 volts per seconds. Volts per seconds. So here the correct option is fourth one. Right? And next is this one. If the ratio of concentration of electrons to the holes in a semiconductor is 7:5, the ratio of currents is 7:4, then the ratio of their drift velocities. So they're asking to find a drift velocities ratio in case of electron to holes. Electrons to holes ratio they're asking. So from this, I is equals to NEAVD. This drift velocity is right directly inversely proportional to n ouతుంది students. Yeah, it becomes n students. Drift velocity inversely proportional to n. And here I, if I write I by n also I can say current. N means number of charge carriers per unit volume passing to the cylindrical wire strings. So in this case, this implies drift velocity in case of electrons to drift velocity of holes is nothing but IE by IH into right NH by NE strengths, because it is having inversely proportional relation there. So we can write like this. So therefore, drift velocity electrons to holes ratio is IE by IH. What is that value? 7/4 according to the given currents. Currents ratio is 7/4 students, and next of this concentration means n ratio students, that is 7/5. That is 7/5. So 7 in the denominator, 5 goes to numerator, inversely proportional relation. So therefore here the answer is 5:4. So the correct option is that fourth option. Fourth is the correct option. Right? And the next. See for this. Initially the conducting spherical shells A and B are at potentials VA and VB respectively. Now sphere B is earthed by closing the switch. By closing the switch, this is earthed. Then potential of A will be, potential of A does not depends on charge on the B students here. The potential difference between the two concentric cells. Let me write for this. Here A is inner spherical cell students. B is outer cell. So I can say that even though earthing for a B, potential difference between A and B does not depend on the outer shell charges. So it will remain the same only. That means again potential difference between A and B is VA minus VB. That's it. It will remain same. Okay. Next. In the formula x equals to 5y z square and z x and z have dimensions of capacitance and magnetic field respectively. So here it is saying that x is nothing but capacitance, z is nothing but magnetic field. C and B students respectively. What are the dimensions of y in SI units? So according to the given, x is equals to 5y z square, my friends. Now this implies that y is inversely proportional to z square and directly proportional to x from this. This implying. So x is capacitance. Basically, what is this x? This is capacitance. Capacitance. Capacitance is nothing but q by v, students. So q by v is nothing but w by q again. So q square. So therefore q is equals to it, students. It means at, we can write squares, right? Divides by w, energy, dimensional formula ml square t power minus 2, right? So therefore for x or capacitance, What we got totally? M power minus 1, L power minus 2, T power, okay, how much students? 4 plus 2. This minus 2 goes to numerator, becomes plus 4, totally plus 4, and A power 2. This is the dimensional formula of X students. Likewise, for B also we have to write Z is equals to B, he told the question. B is nothing but what? Magnetic field. This is nothing but magnetic field, isn't it? Students, B is nothing but F by IL, I will write. Okay. F is equals to Bill sine theta, force acting on the wire, students, while it is carrying current, force acting on it is F is equals to Bill sine theta, formula you know. So from this for Z, therefore for Z, what we can write? Force dimensional formula MLT power minus 2, since if it is ME students, so force dimensional formula divides by I, L means L only. So altogether, what we can write? M T power minus 2, isn't it? Because L gets cancelled, A power minus 1. M T power minus 2, A power minus 1. So the question is that what are the dimensions of Y in SI units? What are the dimensions of Y in SI units? So these dimensions you have to say for this. Y dimension. X by Z square, no? Yes. Dimensions of Y. Therefore, dimensions of Y directly proportional to X by Z square. So therefore, students, what we can write? X, we got like M power minus 1, right? L power minus 2, T power 4, A power 2. Okay. L power minus 2, T power plus 4, A power plus 2. Divides by Z square is there. Z square, students, Z square means it is to be squared. So M square, T power minus 4, A power minus 2. So altogether results M power minus 3. This 2 goes to numerator, students. So L power minus 2, T power 8, A power 4 plus 1. So this is the dimensions of Y. And here our correct option is that first option, right? And the next. The parachutist, after bailing out, falls 50 meters without friction. When parachute opens, it decelerates at 2 meters per second square. He reaches the ground with a speed of 3 meters per second. At what height did he bail out? So parachutist is there, students. So he is falling from height of 50 meters without friction initially. So initially, I can say initially, okay, parachutist. The parachutist falls under gravity, I can say. Falls under gravity. Under gravity. That means, okay, with what speed he has to fall means U square is equals to 2gh, students. So 2g value is not mentioned as 10, so go for 9.8 only. H is 50 meters. So this becomes 980, isn't it? 980 meter square per second square. U square we are writing. So U square we written as 980 meter square per second square. After that, he's saying that he's reaching the ground with a speed of 3 meters per second, right? What happened when he opened? It is decelerating, starts decelerating because of the air resistance. It starts decelerating, students, with this deceleration, 2 meters per second. And finally, he is reaching the ground with a speed of 3 meters per second. At what height did he bail out? So from what height is falling? Total height is asking, students, for us now. So therefore, acceleration, let me write, it is a deceleration. So minus 2 meters per second square. And I can say velocity, with what velocity is falling at 3 meters per second. So suppose if I take v square minus u square is equals to 2as. Okay. V square is 3 square minus u square is, right? U square is 980 students is equals to 2. A is nothing but minus 2. S is nothing but H. Means when parachute opens, this is the case where parachute opens. In that case, we are discussing now. So here it becomes 9 minus this one, students, minus 971. See nothing but minus 4 H1. So minus cancel on either side. So this results, H1 results like a 242 point, isn't it? 4 2s are, 4 4s are. Next 0.7, like that we can get around this many meters, friends. So therefore total height. Okay, H is nothing but HT. I'm writing HT is nothing but 50 meters under gravity height, and when parachute opens, he covered 242.7 meters, right? So therefore altogether, how much, friends? This total 292.7. 292.7 meters is the total height. See the option here. So 293. So 0.7 is there now. So therefore this is equals to 293 meters. That's the answer, friends. Okay. Next you see. The engineer of train moving at a speed of V1 sights a front train at a distance d ahead of him, and on the same track moving in the same direction with a slower speed V2. He puts on the brakes and gives his train a constant deceleration alpha. Find the minimum value of d at which brakes are applied so as to avoid collision. Here the situation is two trains, friends. Two trains are moving. Suppose say this as train. Okay, for example, this is the train, and here another train is like this. Just imagine on the same track, those are moving, and it is moving with a speed v1. He told this is moving with a speed v2, friends. Okay, moving at speed v1 and v2 students, same direction. So like this, these are moving. So in the first train, he has to apply the brake, students, in order to avoid the collision. So then for the deceleration is alpha. In that case, find the minimum value of d, minimum value of distance at which brakes are applied so as to avoid collision. So to avoid collision, okay, what should be the minimum distance if alpha is the deceleration while he applies? So it is very clear that, okay, if v1 is equals to v2, then there is no collision. I can say that if v1 is equals to v2 or even less than v2 this implies no collision. It's very clear, right? Because both are moving on the same track, friends. Both are moving on the same track. So if v1 is equals to v2, there is no relative speed, 0. If v1 is less than v2, definitely it cannot collide the second train. If it is the first train, if it is the second train, so it cannot collide. So relative speed, if I say relative speed, that is v12, that means v1 minus v2, right? Should be 0. So I can say from relative motion, students, relative motion, if I apply for third equation of motion, v square minus u square is equals to 2s. We know that v square minus u square is equals to 2s. From that, v square is equals to u square minus 2as. If I consider relative speeds, v12, okay, first one to second one, students, for all. V, U, and A. So relative speed is 0. Okay, in order to avoid collision, what can you say? V12 must be equals to 0. So V1 minus V2, it's the initial speed, students, whole square, minus 2. A is nothing but relative acceleration is nothing but alpha minus 0. S is nothing but a distance, students. So therefore D is nothing but okay, V1 minus V2 whole square divides by 2 alpha, right? So this is equal or what can you say? Less than also. If it is at this distance, students, at this distance, collision is not possible. So D either equal or greater, I can say now, than this value, then definitely there is no collision. Equal or greater, isn't it? Greater means V1 is less than V2 condition. We don't understand. Okay. Likewise. So the correct option is, see this one, V1 greater than or equals to this value. So first is the correct answer, students. First option is the correct option. And next, two liquid drops with radius R1 and R2 are combined to form a liquid drop of radius R. Suppose this is the liquid drop, radius R. This is the another liquid drop. For example, you take another liquid drop like this with the radius 2R, right? The value of R to form a liquid drop of radius R. Say, students, this is R1, this is R2. Then this is R2, not 2R. This is R2. This is of R2. So these are combining, students, and forming a big liquid drop whose radius is R. These are forming like this. The value of R in terms of R1 not. Value of R we have to say in terms of R1 not. So volume of the bigger drop, volume of a bigger drop, V is nothing but a V1 plus V2, students, where V1, V2 are the volumes of the small drops with the radii R1 and R2 respectively. So volume of the drop will be in spherical shape. So sphere volume is 4 by 3 pi r cube. So R is R in this case for a big drop, and for a smaller drops the radius will differ, students. So for the first R1 and for the second R2 is to be taken. So in this all, I can say this 4 by 3 pi gets cancelled in this all. So R cube is there now. So if I send this side, right, R1 cube plus R2 cube. Here cube root, students, here power 3 is there now for R. So cube root, it's not square root, it's a cube root. So this will be the radius of big drop. See the correct option. Here fourth is the correct option, right? And the next question is this. A coil of inductance 10 millihenry and resistance 0.1 ohm are connected in series across which the battery of internal resistance 0.9 ohm. After the switch is closed, the time taken for the current to attain 80% of the saturation value. It's a formula based question. So I is nothing but I naught e power minus small t by tau, time constant. So he's saying that 80% of the saturation value, the time taken for the current to attain 80% of the saturation means the leftover is nothing but current. Leftover current is nothing but 20% of. So 20% of initial value is left, students. So therefore I naught e power minus t. It's a case of LR circuit, students, LR circuit. So therefore LR circuit time constant is nothing but L by R, isn't it? It's nothing but L by R. So R goes to numerator here. L by R. So this R goes to numerator. This L will be in the denominator. Of course, now here I naught gets cancelled. Here it's 1 by 5. So 1 by 5 is nothing but e power minus t r by L. Let it be. So this can be written as 1 by e power t r by L. So we can say e power t r by L is nothing but 5. So t r by L is nothing but ln 5, isn't it? So ln value to be given, students. Yes, it's given here. Ln 5 given as 1.6. So we require time, I think. We have to find for time. So t is nothing but what we have to write? Ln 5 into L by R, students. Ln 5 given as 1.6. L given as 10 millihenry, students. Milli means 10 power minus 3. Resistance given as 0.9 plus 0.11. See here. These are connected in series. 0.1 and 0.9 are connected in series addition. So this gives us how much? 0.016 seconds, students. So see the option. First is the correct option in this case. First is the correct option. Okay. Next, come to this. A prism of index mu and angle A is placed in a minimum deviation position. This is the minimum deviation position, students. Right? The angle of minimum deviation is A. So minimum deviation is nothing but angle of prism according to the given. Value of A is asking in terms of mu. A value is asking in terms of mu. So let me write the formula. First, in case of prism, refractive index is nothing but sine of A plus minimum deviation by 2 whole divided by sine A by 2. It's this formula, straight formula we have. So in this case, mu can be written like this. So sine A, this minimum deviation also given as A. So therefore, we can write like this. So what we got finally here? Sine 2A by 2 means sine A, students. Sine 2A by 2. Sine A by 2. Sine A by 2 is mu. So thereafter, sine A, here if you see the options, sine inverse mu by 2, sine inverse mu minus 1, like that, different cos sine values given. So we have to write this in terms of cos. So what I can write for this is sine A can be written as 2 sine A by 2 into cos A by 2, students. We can write like this by sine A by 2. So on sine A by 2 gets cancelled. So 2 cos A by 2, students, is equals to mu. So from this, it's very simple now, right? Cos A by 2 is nothing but mu by 2. A by 2 is nothing but cos inverse A by mu by 2. A is nothing but 2 cos inverse mu by 2. This is the A. See for the option, correct option. There it is our third option. Yes. Yes. Now see for this. Carnot engine means thermodynamics, second law based question. A Carnot engine operating between T1 and T2, right, has efficiency 1 by 6. When T2 is lowered by 62K, its efficiency increases to 1/3. Then T1, T2 are respectively. Students, efficiency, eta is nothing but 1 minus T2 by T1. This is the formula what we have. Here is saying that in first case 1/6 and second case 1/3, 1 by 3, 1 by 6, 1 by 3. So for the T2 is lowered to 62K, lowered by, not to, it is lowered by 62K heat load. So from this efficiency equation, we'll proceed now. In the first case, 1/6 it is given, students, 1 minus T2 by T1. So T2 by T1, we don't know values. So from here, T2 by T1 can be written as, what can we write, students? 1 minus 1 by 6. 1 minus 1 by 6 means 5 by 6. Let it be. T2 by T1 is 5 by 6. And second case, 1/3, 1 by 3 is nothing but 1 minus. This T2 is lowered by 6, lowered to 62 heat load. So T2 becomes T2 minus T2 strength, 62 strengths now, divides by T1. Okay. Here actually this is T2 dash. If I say T2 dash is nothing but T2 minus 62. So that's why we written like this. So if you are simplifying for this, what can we say? 1 minus T2 by T1 plus 62 by T1, I can say. Okay. So we got 1 by 3 is equals to, right? This can be written as 5 by 6 students here. 5 by 6. So 1 minus 5 by 6, let me write, plus 62 by T1. 1 minus 5 by 6 means what? 1 by 6 students. So that 1 by 6 I'm bringing to LHS, 62 by T1. So LCM is 6 here, 2 minus 1, 1, that is 62 by T1. So this implies T1 as, okay, 6 to the 12, 36 plus 1, 37. So 372 kelvins is the T1 value. Is asking to find T1 and T2 also. T2 also you have to find. So use this equation. Which one? Use this one. So therefore, T2 by T1 is 372 is equals to 5 by 6. Is equals to 5 by 6. So how many times? 6 6 are 6 2s are. It goes. So T2 results are like 5 2s are 10. 30 plus 1, 31, 310 Kelvin strength. So T1 372, T2 310, which is the correct option. So this first is the correct option, students. First is the correct option. And the next. A proton, an electron, and helium nucleus are the same energies. So energies are same, students, for all this. They are in circular orbits in a plane due to magnetic field perpendicular to the plane. Let RP, RE, RHE be their respective reading. So here it's given as proton and the next electron and helium strands, right? So if I write the increasing order of masses, I can say electron mass is less than proton and then maybe for helium. So mass of electron is less than mass of proton is less than mass of helium, right? Because he's asking to compare the radii, students, for these three particles. So radius in circular path is nothing but mv by qb, right? mv by qb, centripetal force. If you're taking from that, we can write like this. So energies are same is saying that energies are same means which energy? Kinetic energy, basically. Kinetic energy is same for all of this. So kinetic energy is half mv square, students. So v is nothing but root over 2k by m. So k same. So therefore v and r given like this. Right? R is nothing but, so therefore r is nothing but, so m by qv. From here I'm writing. So this v is there now. In place of v, this we are writing. So this means root over 2k by m. So this implies that radius is inversely proportional to small m. Since k is constant, right? And root over mass, not inversely proportional, so it's directly proportional only. And inversely proportional to charge, because this mass is there now. This mass, when you bring into this square root, it should be written as m square. One m gets cancelled, one left there. So therefore, like this. Here K and B are constants, friends. Kinetic energy is same, and magnetic field is also constant. So we have to take this relation as help, and we have to say. So therefore, radius of electron to radius of proton, radius of helium, if I take, that means root over mass of electron by charge of electron is small e, is to root over mass of proton. So let me retest like this. Again, proton charge is small e. Root over mass of helium is nothing but 4 times of mass of proton divides by 2 times of charge of proton. So if you observe carefully for this all, see, this root 4 means 2 only. So this is equal. These two are equal. These two are equal. But this is not equal here. So what I can say is that radius of electron is not equals to radius of proton, which is equals to radius of helium. This condition you have to check it. Not equal, and we can write it as the less than also, no? Less than, definitely, because mass of electron is less than mass of proton. So see the third option here. Radius of electron is less than radius of proton, which is equals to radius of helium. So likewise, next, two satellites A and B having are revolving around a planet in coplanar and concentric circular orbits of radii r1 and r2 respectively. In the same sense, the respective periods of revolution and 1 hour and 8 hours respectively. This is revolution r, I think, yes, r here, yeah. The radius of orbit of A is equals to 10 power 4 kilometers. What's their speed when they are closest? So students, here planets, satellites are revolving in circular orbits. Say this is one and this is another one. Say this is the satellite and it is another satellite. This is A, this is B satellite, right? So this is moving with R1 radius and this is moving with R2 radius. That case from Kepler's law, Kepler's third law we have. Kepler's third law. What we have T square directly proportional to R cube. Square of the time period is directly proportional to cube of the semi-major axis. Right? So therefore from here T1 by T2 whole square. T1 by T2 whole square is nothing but R1 by R2 whole cube. Whole cube strengths, right? T1 by T2, 1 and 8 given strengths, 1 by 8 whole square is equals to R1 by R2 whole cube. Isn't it? So it means 1 by 64 is equals to R1 by R2 whole cube. So therefore I can say that R1 by R2 as from this 1/4 na strengths, 4 cube is 64. So R1 by R2 is, so R2 is nothing but 4R1. This is another conclusion we got. Okay, let it be. Now what is asking actually radius we got. The radius of orbits of A equals to 10 power 4 kilometers. R1 given as 10 power 4 strengths. This is R1 now. This is R1. What is their relative speed when they are closest? Relative speed is asking students. V12 is nothing but V1 minus V2. Of course, 1 and 2 nothing but A and B here. So V1, V2 we should find students now. What is V1? Speed of the first satellite. Speed is nothing but distance by time. What is distance? It's nothing but 2 pi R1 by time. By time. Okay. Okay, T1, let it be T1 first. T1 is 1 hour actually. So therefore, if I write 2 pi, R1 is 10 power 4. Just now you are seeing by T1 is 1. So this is V1 is nothing but a 2 pi into 10 power 4 only. Okay, this is of kilometer per hour, na per second, per hour, kilometer per hour, students, per hour. This V1 value. Likewise, V2 will find and then we'll take the relative speed. Therefore, V2 likewise, similarly, V2 is nothing but 2 pi R2 by T2. Where here R2 is nothing but 4 R1 students and T2 is nothing but 8. We remember, it's 8. So therefore, it results like this 2 pi into 4. R1 is nothing but 10 power 4 divides by 8. So how much it is? Just pi into 10 power 4 on, because 2 4s are 8. The numerator, the denominator, 8 is there. So V2 comes like this 10 power 5 into 10 power 4 kilometer per hour, students. So this is the V2. So we want a V1 minus V2. So that means V1 is 2 pi and here it is pi. So therefore pi into common is 10 power 4, students, in this are right, kilometer per hour. So this is the relative speed. Check for the correct option. Here it is the first option, pi into 10 power 4 kilometer per hour, right? And the next is the cylinder of radius is smaller and thermal conductivities K1 and K2 are surrounded by cylindrical shell of inner radius smaller and outer radius 2 are whose thermal conductivity is K2. There is a loss of heat across cylindrical surfaces when the ends of the combined system are maintained at temperatures T1 and T2. The effective thermal conductivity of the system in the steady state is. So here are two cylinders. We just imagine here. This is the first cylinder whose radius is R, and it is surrounded by another cylindrical one, students, whose conductivity is K2. Here conductivity is K2, but the first K1 is the conductivity, thermal conductivity. Here there is no heat loss. There is no heat loss. Okay, between these two. Right. Once again, see for this cylinder of radius R and thermal conductivity is K1. Is surrounded by cylindrical shell of inner radius. So students here, okay, inner radius and outer radius. If you are taking this, inner radius is R1, outer radius is R2. Right. R2 means 2R, students. It's given as 2R. Outer radius 2R, inner radius R, whose thermal conductivity is K2. And there is no heat loss when the ends are combined. These ends are combined and the maintained temperatures T1 and T2. T1, T2 are the temperatures. Effective thermal conductivity, K is asking, students. K is nothing but K effective is asking. Effective thermal conductivity is asking. So definitely these two are at a constant rate of flow, students. Constant rate of flow means rate of heat is constant, I can say. Rate of heat is constant. Is a constant. Rate of heat means what? dq by dt. It's a constant between these two cylinders. So here inner with the inner radius and outer radius cylindrical shell surfaces you have to observe. Shell outside is the shell. Shell it has with R and 2R radii. Inside with R1. Okay, inside with R1 cylinder is placed. R inside it is R. Okay, here R1 R2 for the shell, inner and outer. That is so. Therefore, it is here R1 is nothing but R again. Here it is R. Here it's a 2R, students. So we have to keep this all in mind. So rate of heat is same, na? Okay, fine. So then what we can do is dq by dt for inner cell plus dq by dt for outer cell must be equals to, students, dq by dt total. And the total heat flow total heat flow becomes like this, students. Okay. Now dq by dt, what we have formula for rate of heat? Rate of heat means dq by dt is nothing but basically what's the formula we have? Transmission of heat. That means Ka dt by L. This is the formula. K, conductivity, quotient of thermal conductivity. A is the area of cross section. dt is the temperature difference. L is the length for which heat is traveling. dt here, this t is time. Here, this dt is temperature change, students. We remember. So if I'm writing for this inner and outer cells, right? So K1, okay, inner pi r square area. So T2 minus T1, between those two, temperatures are different, T2 and T1 by L, that is nothing but, okay, it means L is nothing but L only here. For all it will be the same only. And next, students, here, for outer K2, no? Thermal conductivity K2 pi. Here, this is nothing but a 2r square minus r square, students, pi r square, inner and outer, into this is T2 minus T1 again, all divided by L, is equals to total, no? For total, if I write K pi r square, r is nothing but a 2r, students, and this is temperature changes T1, T2 minus T1. So this is L. So if you see carefully, the K pi by L is this one, pi L gets cancelled in this all, pi and L gets cancelled in this all. All right, if you are rearranging, we'll get, so this like this will get, students, K1 plus 3 K2 by 4. See the option. Option 3 is correct, students. Option 3 is correct. Right? The cylinder you have to imagine until this edges, students. This edges until this edges, same length, no? So until this edges, you have to imagine. This is the answer. Next, two rod A and B of identical dimensions are at temperatures 30 degrees centigrade. If A is heated 24 up to 180 degrees centigrade and B up to T measured degrees centigrade, then the new lengths are the same. New lengths are the same. The ratio of quotient of linear expansion of A and B is 4:3. The value of T is. In case of quotient of linear expansion, students, expansion on okay, metals will expand upon heating, students. So delta L is nothing but change. So new lengths are saying same like that is saying. So I can say delta L1 is nothing but delta L2, students. Delta L is nothing but L alpha delta T, students. Okay. Here also L alpha delta T, students. It's a constant. So alpha 1, alpha 2 terms should come. The delta T is nothing but a temperature difference, students. Okay. For the first rod, left side I written. For the second rod, it means for A, left side, and for B, right side, I written this formula. Now in this case, lengths are going to cancel, and now therefore delta theta 2 is nothing but a T here actually. It's nothing but capital T. So delta T2 is nothing but capital T, this one. So alpha 1 by alpha 2 into delta T1, students. So correspondingly, values alpha 1 alpha 2 mentioned 4/3 ratio. Ratio given as 4/3. And the delta T is nothing but okay, 30 to 180, students. So that's 150. So therefore 200 degrees centigrade T here. So otherwise you name this as delta T only. First, later we can write this as capital T, no problem. Delta T2. So delta T2. So now this total temperature is nothing but 200 plus previously 30 degrees is there. So altogether 230 degrees centigrades. 230 degrees centigrade. So here it's the first option. Right. The next is One end of massless string of length L connected to a particle of mass M and other a small peck and smooth horizontal table. If the particle moves in a circular path with constant speed V, the net force on the particle in ground frame is. Students, here massless string to be assumed here, like this particle is connected. Okay. On smooth horizontal table, you have to imagine this. So on the smooth horizontal table, it is moving in a circular path with a constant speed. V is constant. V is a constant. On the smooth horizontal table, from one end, you imagine this arrangement. Net force on the particle is, right? Net force on the particle means towards this fixed point, it is T1 distance. So like this. It means the tension is, this is providing the centripetal force. But it's a circular motion. T is nothing but mv square by r. So here T is nothing but mv square by L. L is the length of the string. Like that if you consider. So this tension is only providing the centripetal force. So the option is first one, students. And next, series 118. So here A to B and okay, C to A to B, B to C. Like this it's mentioned. Process. 2 moles of ideal monatomic gas is undergoing a cycle whose internal energy versus volume plot is given, R value given, universal gas constant, PV plot of the cycle. So we have to choose the correct option in this. So students, the A to B process, suppose if you see A to B, like this it's going now. Constant you can observe. That means temperature is constant. Okay, A to B, this one A to B. A to B, in this A to B, U constant, students. This implies U constant. U constant means temperature also constant. Internal energy temperatures directly proportional. So then we can say P is inversely proportional to V. For BC, if you observe volume constant, BC. This is volume, students. This axis, meter cube is there now. So BC volume constant. So volume constant means internal volume constant. For BC, what I can say, for BC, volume constant and internal energy increasing. That means temperature also increases, right? Volume constant means, okay, pressure can increase. Pressure can increase. So keep this in mind, you see. Right. A to B volume constant. A to B energy constant, temperature constant. So this you can say for this. And B to C. B to C, what is the observation here? Volume constant. B to C volume constant. So the second option is correct, students. It is matching. Second option is the correct one. Next, the temperature at which the RMS speed of oxygen molecule will be sufficient for escaping from the Earth approximately. So is asking to find the temperature. Temperature is asking to find. Yes. What will do for this? Yes or no? Here I can say CRMS RMS speed. In order to escape, it must be greater than or equals to 11.2 kilometers per second, students. So it must be greater than or equals to 11.2 escape velocity on that surface. And also CRMS formula by definition, CRMS. Okay, root mean square speed, students. CRMS means is nothing but a root over 3RT by m. 3RT by m should be greater than or equals to 11.2. 11.2 kilometers. Suppose if I write in SI units like this. So now your R value given, M value. How much, friends? 3 into R value given as 8.3. This T divides by M. Molecular weight of which gas? Oxygen. O2. O2 means 16 into 2, 32. So 32 molecular weight. So in grams, 2 kilograms, if I write this much, it is under square root. It's greater than or equals to 11.2 into 10 power 3. So solving for this T, we'll get our answer, right? Like this, 1.1. 1.61 into 10 power 5 Kelvin, students. So third is the correct answer, right? It's basically from formula only, formula based question. Next question. Transistor is connected in common emitter configuration. So C configuration. And collector supply is 8 volts. Okay. Voltage drop across the resistor is 800 ohms. In the collector circuit is 0.5 volts. If the current gain factor alpha is 0.96, and the base current is. Basically, students, for any configuration, emitter current is nothing but a sum of base current plus this collector current, as we know. So from this is asking to find the base current. So that is nothing but emitter current minus collector current. And also given alpha as point, how much it is given? 0.96 now. Yes, 0.96. Alpha means what? Basically IC by IE. IE, that is given as 0.96. So from this IE can be written as, suppose if I write for IE, IC by alpha, that means IC by 0.96, let it be. IE value, we know, yes, in terms of IC we can express now. So in this, if you are substituting this value, IB will get, IB is nothing but IE means IC by 0.96 minus IC, isn't it? So that which is equals to IC of 1 by 0.96 minus 1, right? What is IC? How to get IC? Here IC is nothing but IC equals V by R. So about the collector region. So VC by RC, students. So therefore IC, what is VC? VC, collector voltage 0.5 volts. Collector voltage 0.5 volts. And this is given as 800 ohms resistance there only. So therefore it's of 800 RC. So this means of 5 by 8. Okay, milli, it will become milli, student. It will become like milliamperes. 10 power minus 2, here 0.5 is there, so milli. So I can write like this, 5 by 8 milliamperes. So 5 by 8 of, okay, 1 by 0.96 minus 1. So this will result like 26 microamperes, friends. Right? 26 microamperes. We'll get like that. That's the value of base current. Next. After this, a message signal of frequency 20 kilohertz and the peak voltage 10 volts. This is a signal and is the voltage, signal frequency, voltage, and a carrier frequency given as 1.5 megahertz. So message signal of frequency 20 kilohertz and peak voltage of 10 volts is used to modulate a carrier signal of frequency 1.5 megahertz and a peak voltage of 40 volts. The sideband frequencies are. Sideband frequencies means what, students? Sideband frequencies. These are nothing but carrier wave frequency plus or minus signal or message frequency strands. So therefore, if I write for this, see here, carrier wave, what's the frequency given? 1.5 megahertz. So therefore, 1.5 megahertz plus or minus 20 kilohertz, 20 kilohertz. So all the options are given in kilohertz, students. So that's why better to convert into kilohertz. So 1.5 kilo, that means 1500 kilohertz plus 20 kilohertz. This is one value. And another value is that 1500 kilohertz minus 20 kilohertz. So 1520, okay, this value and 1480. So first option is the correct one, students. For this, 1520. For this, 1480. Right? Kilohertz. So first is the correct option. Next. Two cells of EMFs approximately 5 volt and 10 volt are connected to be accurately compared using potentiometer of length 400 centimeters. So potentiometer length, it is just 400 centimeters and okay, cells EMFs are given as 510 volts. Right? So length is just 400 centimeters on distance. Now what is asking in that case, the battery that runs the potential should have voltage of 4 volts, right? The battery potential can have voltage 15 volts and are connected in series with its adjuster so that potential drop across the wire slightly exceeds 10 volts. So here I can say that the balance point can be obtained only if the potential difference across the wire is greater than the EMFs of the cells strengths. While we are comparing the cells EMFs, comparing to that, potential difference across the wire must be greater. Otherwise, balancing point cannot be obtained. So this option is suitable. The battery of potentiometer can have voltage of 15 volts because this 5 plus 10, 5 plus 10 is 15, right? 15 volts. So can have voltage 15 volts. Okay. Exceeds the 10 volts. And yeah, it means that here it's 10 volts is then greater than this, means greater than 10 volts, it is possible to get balancing point. So the correct option is second one, students. And the next is two waves of equal amplitudes and frequencies which have one phase initially interface each other. The ratio of intensity when the two waves arrive in phase to that when they arrive 90 degrees out of phase is. So resultant intensity we have to find, students, here. Okay. So intensity, resultant intensity. I is nothing but 4 I naught cos square pi by 2, students. This is the formula what we have for resultant intensity. So therefore I1 by I2 was first one is in phase, that means 0 degrees, second one is 90 degrees, students. First one he told in phase, second one is 90 degrees. So therefore I1 by I2 is nothing but a cos square pi by 2 by cos square pi by 2, means pi means pi 1 first case, here second case pi 2. So it's of cos square 0 by cos square 90. Cos square 90, our students. 90 by 2. 90 by 2. Means it is 2:1, students. The correct option is third option. Next. A simple pendulum of length L and having bob of mass n suspended in a car. The car is moving on a circular track of radius r with uniform speed. V, right? So in that case, the pendulum makes a small oscillation about its equilibrium position, then the time period is suppose like this, right? If you imagine, okay, in that case, strange, what happens in this direction? G takes place in this direction, A takes place in this direction, effective G test should take place G, and A should take place like this. G dash is the resultant acceleration. So G dash is nothing but root over. Okay. What I can say, this is suppose in this direction G, na, right? Plus in this direction acceleration A. A is nothing but what, students? V square by R, na? A is nothing but V square by R. It is to be square, na? So like this. So V square by R, V power 4 by R power 2, and so therefore T is nothing but, basically you know that T is nothing but 2 pi root over L by G. So T dash is nothing but, now here in this case T dash is nothing but 2 pi root over L by G dash. Now for this G dash we are seeing here. So fourth is the correct option, students. Fourth is the right answer. Next. The velocity of the wave on the surface of water is proportional to lambda power alpha, rho power beta, G power gamma, where lambda is wavelength and rho is the density, G is the acceleration due to gravity. The correct relation is, right? What can we write for this? V directly proportional to, what is V? Velocity, friends. Lambda power alpha, rho power beta, G power gamma given. So for velocity LT power minus 1 with M power 0, students. Lambda means L power gamma, G density, mass by volume. So mass power M power beta, volume L power minus 3, it is 3 beta. Next, likewise G means LT power minus 2. So therefore L power gamma, T power minus 2 gamma. We can relate like this. So now if you're writing 0 for beta, M power, isn't it? M power, if you are comparing, M power 0 is beta. Next, alpha is nothing but 1 is nothing but real power 1, 1 is nothing but alpha minus 3 beta plus gamma. This is another equation. Next, minus 1 is nothing but T power minus 2 gamma. So from this gamma is 1 by 2, beta 0. So 1 is nothing but 1 minus 3 beta. So beta 0 plus gamma, gamma is 1 by 2. So therefore alpha plus 1 by 2 is 1. So therefore you can say that alpha is nothing but 1 by 2. So here you can say that alpha is equals to gamma, which is not equals to beta. This is the relation. See where it is. Alpha is not equals to beta. Gamma, no? See this one. I think this one, you know? See the option, correct option. Alpha 1 by 2, gamma 1 by 2. Yes, not equals to beta. Yes, this one, you know? Yes, third option is the right one. Correct only. This is the correct. And next, variation of velocity of particle moving along straight line has shown the distance traveled of the particle in 4 seconds. 4 seconds means the total graph to be taken, means 4 seconds. So area means the distance is nothing but area of the graph. Area of the graph. Which graph? This is VT graph. So area of the VT graph, students. So just divide like this, students, to get the area. Like this you divide. Say this as the first one. This is second one, this is the third one, this is the fourth one. Area to be calculated. So that is nothing but a distance. Distance is nothing but first one half base into height. Base is 1, height is 20, right? This is the first, and the second base 2 minus 1 1 into height is 20 plus, right? What is this? Third is like this now. So 4 minus 2 2, 2 into 10 students plus half base is, okay, this one base is 1, the height is 10 students. See this carefully. This height is 10 only, right? So get the value. So 20 by 2, 10 plus 20 plus 20 plus 5, 55 meters is the answer. 55 meters is the answer. First is the correct one, and the next one. So you given as AI plus BJ plus CK, where IJK are the east, north, vertical directions. East, north, vertical means upwards. You just imagine students, K. In that direction, C is there. In this direction, C is there. C cap is acting. C, not cap, C is acting. That's it. C is acting in this direction. Right? Now, what we have to answer? Maximum height of the projectile is, maximum height is nothing but u square by uy square by 2g, na students, maximum height case. So uy is nothing but c only, na here, c square by 2g, c square by 2g. Third is the correct answer, students. And next, the work function of a metal is 2.5 electron volts. The maximum kinetic energy of the photoelectrons emitted if radiation of wavelength 3000 angstroms falls on it is H given, C given. Work function given, students. Work function given as 2.5 electron volts. So wavelength mentioned, lambda mentioned, and the H values are also mentioned. So from Einstein's photoelectric equation, I can say that from Einstein's photoelectric equation. What is that equation we have? Kinetic energy of the photoelectron is nothing but 12,400 by lambda in angstroms. It should be in angstroms minus work function strengths. Now this energy will be in electron volts. This is the Einstein's equation we have. Right? Now you see. So 12,400 by lambda is 3,000 angstroms minus work function is 2.5. Now all you are going to get in electron volts. So it is nothing but right, 12.4 by 3. That means 1.5. But 4, na? 4 point something. 4.13 like that you are going to get minus 2.5 electron volts. So therefore, it's around 1.5, around 1.5 electron volts. Now this you should convert it into joule, students. So that 1.5 into its around value, close value. 1 electron volt is nothing but this many joules, 1.6 into 10 power minus 19 joules. So if you're calculating, you're going to get 2.61 into 10 power minus 19 joules, students. This is the answer. So the correct option is 4. Okay. Correct option is 4. Now sun radiates energy at the rate of, so d by dt at the rate of 3.6 into 10 power 26 joules per second. The rate of decrease of mass means dm by dt is asked. So from E is equals to mc square, students, d by dt is nothing but a dm by dt into c square. So therefore dm by dt to be answered now. dm by dt is nothing but dE by dt whole divided by c square to be written. So what's the value? Can anybody say? Given value is 3.6 into 10 power 26 divided by c square means 3 into 10 power 8 whole square, students, 9 into 10 power 16. So we're going to get this many kg per second, students. 4 into 10 power 9. So the correct option is third one, students. Right? A particle starts from rest and travels a distance s with an uniform acceleration, then it travels distance 2s with uniform speed, and finally travels distance 3s with uniform retardation comes to rest. If whole motion is in straight line, the ratio of maximum velocity to the average velocity is. Maximum velocity to the average velocity is asking. V maximum to V average is asking, students. So the given case is like this. Yes, distance it is traveled, suppose like this, with uniform acceleration, and after some time, distance with uniform speed. If I take this as speed axis, this as time axis, then it is retardation, right? Uniform acceleration, uniform speed, right? Like this. Starts from rest. So this graph is okay, friends. Now this is s distance. Now this is 2s distance, and this is 3s distance during this time. So say this as ABC, D points, and say this as E and F points. Let it be. Now this is the time axis. Okay, x-axis is time axis, and this is the speed axis, friends. So maximum velocity to average velocity is asking. Maximum velocity is v only, friends. So average velocity to be calculated. Average velocity is nothing but v average is nothing but total distance by total time, friends. This total distance is nothing ds plus 2s plus 3s, students, by total time, which means t1 plus t2 plus t3 is the total time. So 6s by total time. Time is nothing but distance by speed. So here also distance by, how you are going to get this distance by time? So s is equals to half at square if you are taking half ut, half vt, means distance is area, na? So vt. S is nothing but distance for the time t1, students. V is the maximum. So you are going to get for the t1, this has 2s by v now. So that's why we written. Next, likewise, for the second, if you're writing, this is the first t1 time, for the t1 time. Next, for t2 time, 2s is nothing but half. Is there no half? Area is not like that for this. It's just area like multiplication of length and breadth. So yes, multiplication of lengths and breadths. What are you going to get for this 2s? So v into t, simply what I can say, v into t2. So therefore t2 is nothing but 2s by v. So here also 2s by v. Next, likewise for t3. For t3, what distance it is taking? 3s. 3s is nothing but v into half. Of course, triangle is forming now. Yes, half v into t3, students. So this is 3s. So therefore t3 is nothing but 6s by v, isn't it? So therefore 6s by v we should type. So now that is nothing but total. So in this, so writing for this 6s by v goes to numerator. So right here 10s, here it is 10s. So therefore 2 3s are 2 5s are. So 3 by 5v is v average. Whereas v max is v only, students. So therefore ratio of this v max to v average is nothing but v by 3 by 5 v. So that means 5 by 3. So the correct option is third one, students. Third is the correct answer. Okay, like this. And next, two girls weighing 40 and 60 kg are at their stand at A and B and are 10 meters apart. Right? They pull on massless string stretched between them, then they will meet at where they are going to meet. For that, we have to answer. Yes, see for this. Okay, two goals, their masses are given, students. Their separation is given, mass is given, separation is given. They pull on mass restraint stretched between them, then they will meet it. Suppose A and B are assumed here, students. Suppose X center of mass is like this, XCM is here, right? Your mass 1, your mass 2 means two students, like two girls' masses are to be taken there. So this is the XCM from this reference. Reference frame is fixed. If it is fixed here, origin is fixed here. X1 will be 0. I can say X1 will be 0, whereas X2 is nothing but how much it is? 10 meters. That's given as 10 meters. 10 meters. So keep this in mind. The XCM is nothing but M1 X1 plus M2 X2 divided by M1 plus M2 if you're writing. So this is nothing but M1 into 0. X1 is 0 now, M2 is, right? Let it be M2 first and then later we'll substitute here M1 plus M2. So in the next step, M2 is 60 into 10 by 40 plus 60 students. So 600 by 100 means 6 meters. 6 meters from, I can say A. From A it is. Center of mass is 6 meters from A. So second is the correct option, friends. Second is the correct option. The substitution formula based on. And next. A mass M is suspended to a spring of length L and force constant K. The frequency of vibration is F1. The spring is cut into two equal parts and then each half is loaded with the same mass. The new frequency is given by. So when spring is loaded, then frequency will increase, students, definitely. That's the first observation you should have. And the next case is frequency equation. If I write the first case, F1 is nothing but 1 by 2 pi root over K by M, students. Okay, it's the loaded spring case. So K by M. This is the frequency, right? Reciprocal of time period, students. If it is time period, here M by K in the root will get. Okay. And the K, here K is actually this K is there now. K1, K2 we should write here. K1 is nothing but mg by delta L, students. Likewise, K2, if I write K2 is nothing but mg by two equal parts is making into two equal parts. So it will become half, students, delta L by 2. F is equals to kx now, students. So if you cross multiply, you'll get F. Mg is nothing but F only, na? Like this. So we can write like this. K1, K2 values we can write. So in that case, this is equals to 2 K1 also. This is equals to 2 K1. So therefore now if I write for F2, 1 by 2 pi root over, it's K1, it's K2, students, K2 by M. Right? So that is nothing but, it's K2 is nothing but 2 K1 now. From this, what I can say? K is under root, so 2 to 2 into F1. So this is the correct option, students. Root 2 F1 is the correct option. It's also again formula based. Large tank filled with water to a height is to be emptied, okay, through a small hole at the bottom. The ratio of times taken for the level of water to fall from H to H by 2 and H by 2 to 0. So the ratio of time taken, they're asking, students. Basically, time taken is nothing but to fall. Time taken is nothing but root over 2H by G to fall. Right? The first case, if I say from H to H by 2 have to fall. So root over T is nothing but T1 is nothing but root over 2 by G. H means here H2 H by 2 you should take, students. H2 H by 2 under root only. Right? Under root only. without getting confusion, I'll write like this: root h1, root h2, right? Like this. So that means root over 2 by g, root over 2 by g into 2h, I can say root 2h, h can be taken out, isn't it? 1 by root 2, students. 1 by root 2 I can write. Right? Can we write 1 minus 1 by root 2? No? 1 minus 1 by root 2. Yes, 1 minus 1 by root 2. Yes, this is. This is the first case. That means from h to h by 2. Next, from h by 2 to what he told? 0. He told. H by 2 to 0. Right. So therefore T2 is nothing but root over 2 by G into root of H by 2 minus 0. That's it. Right. So that is nothing but root over 2H by G into 1 by root 2 will get. This is asking the ratio of this T1 by T2. What will get, students? T1 by T2. Say this is second equation, this is the first equation. We'll get a root 2 minus 1, students. Root 2 minus 1. So root 2 minus 1 is in the third option, students. Right? Root 2 minus 1 is in the third option. Next, 134th. A glass capillary tube of inner diameter 0.28 mm is lowered vertically into water in a vessel. Capillary tube is lowered vertically, students. The pressure to be applied on the water in the capillary tube so that water level in the tube is same as that of the vessel. So when we dip this capillary tube in such a way that having tube diameter as 0.28 mm vertical inside the water, it is dipped. The pressure to be applied on the water in the capillary tube so that water level in the tube is same as that of before is asking. So students, I can say surface tension T is nothing but HRDG by 2, students. So pressure is saying, that's why HDG I take inside the bracket. So RP by 2. So this implies pressure as 2T by R. Right? This implies pressure like that. So therefore pressure is nothing but 2 into how much for this surface tension given? 0.07 by our radius, how much it is given, students? It's a diameter by 2 means 0.14 millimeters, so 10 power minus 3. So this results like 10 power 3 Newton per meter square. So 10 power 3 Newton per meter square. Now is asking the total pressure, I think. Yes, total pressure you have to ask. The pressure to be applied on the water so that. So total pressure is nothing but. So P total is nothing but this P plus atmospheric pressure, students. So this P is 10 power 5 plus atmospheric pressure is, sorry, this is nothing but 10 power 3. Atmospheric pressure is nothing but 10 power 5, students. So nothing but, you can write like this, 10 power 3 plus 100 into 10 power 3. So which means 1 into 10 power 3 here. So 101 into 10 power 3, students. This many newtons per meter square. 101 kilo. So fourth is the right answer, students, for this. Fourth is the right answer. Next, 135. A glass flask of volume 200 centimeter cube, okay, is completely filled with mercury at 20 degrees centigrades. The amount of mercury that split over when the flask is heated to 8 degrees centigrades is quotient of volume expansion given for glass and mercury given. Okay. Here first the flask volume they given, students, completely filled with mercury at 20 degrees centigrades, and it is filled in flask heated to 80 degrees centigrade. So if I say change in temperature from 80 to 20 to 80 when it comes, that means 60 degrees centigrades. Increase the volume of flask and mercury still fine, students. In the first case, increase in the volume of flask. First I will find flask in terms of this one, coefficients are there, no, students. So increase in volume, delta V is nothing but V gamma delta T, students, according to the formula. Coefficient of expansion, volume coefficient of expansion, gamma is. So volume given as 200 units, they given 200 centimeter cube. Gamma, are they given, students? They must give gamma 27, right? So therefore 27 into 10 power minus 8, students. And the delta T is 60, students. Now this is delta T. This is delta T, 60 degrees. So therefore we'll get answer for this. How much answer are you going to get? 27 into 2. Okay. Or 5.24 now. So 2 sevens are 14. Okay, 54 into 6 is there. So this one will be like this, students. 3.24 here. Yes. So this results 3.24 into 10 power minus 3 centimeter cube. So the second case is that increase in volume of mercury, increase in volume of mercury. Mercury, in this case, delta V is nothing but V gamma delta T again. So volume in this case, so 200 into 0.18 according to the given, into 10 power minus 8 according to the given, students, into temperature change is 60 degrees only. So this, if you are simplifying, will get this value. So here, if you observe carefully, so this is the case of mercury, this is the case of flask. Flask volume is greater than the this one mercury volume. So definitely do not split. It won't split from that flask, students. Flask expansion is more than mercury expansion. Mercury expansion is just 2.16 into 10 power minus 5. Here it is 3.24 into 10 power minus 3. So therefore, flask is expanding much greater than mercury. Due to that reason, it won't split. So the answer is 0. What is asking? The amount of mercury that split over when the flask is heated to 80 degrees. It won't split. Right? So next. A liquid of mass m and specific heats S heated to temperature T, another liquid of mass m by 2 and specific heats heated to temperature T. These two liquids are mixed, the resultant temperature of the mixture will be. So from principle of calorimetry, so this is from calorimetry principle, students. Calorimetry principle. What is that calorimetry principle? Heat given, okay, by the hot liquid equals to heat taken by the cold liquid, and we can select that. So heat given by the hot liquid is equals to heat taken by the cold liquid. So therefore, you know that MST. So M1 S1 T2, sorry, T1 minus T, where T is common temperature, students, is nothing but M2 S2 Okay, this common temperature minus lower temperature. T1 is higher temperature, T is common temperature, T2 is lower temperature, students. So masses are given like this, m by 2, S is given as 2s, and 2t minus t is equals to ms small t minus capital T according to the given. This values m by 2, 2s, you see, all these values we are substituting. So therefore here it gives a 2t minus small t is nothing but t minus capital T. So 3t is equals to 2 small t. So small t is nothing but 3 by 2 into capital T. 3 by 2 into capital T. So see for the option. So this is the fourth option. Here it is the fourth option, small t value, right? And next 137. In Young's double slit experiment, right, interference pattern is obtained on screen by light of wavelength 6000 angstroms coming from the coherent sources. S1 and S2. At certain point B on the screen, third spot is formed. Then the path difference in micron is, right. Young's double slit experiment is saying about which fringe, bright or dark students. For that we have to know first. By light of wavelength is the lambda. Point is third dark. Yes, third dark. This is important, students. So we have this formula, path difference for the case of dark. For the dark fringe, path difference is 2n plus 1 of lambda by 2, where n starts from 0, students, in this case. If I write plus, here n should be starts from 0. So this is a path difference. So for third dark, n should be equals to 2. So therefore delta x is nothing but 2 into 2 plus 1 by lambda by 2, right? So altogether, what I can say? So 5 by 2 lambda. Lambda is nothing but 6000 angstroms. 6000 angstroms means this much meters. 6 into 10 power minus 7 meters, because in microns is asking. So that means 1.5 into 10 power minus 6. So answer is 1.5 students. Second is the correct answer. Next. 4 into 10 power 20 electron volts of energy is required to move charge of 6.25 coulombs between 2 points. The potential difference between them is. So students, potential difference basically V is nothing but energy by charge. What is this energy here? 4 into 10 power 20. Here volts are their units. So therefore, this should be converted into SI units. So therefore, this one electron volts first. So 4 into 10 power 20 into 1 electron volt is nothing but 1.6 into 10 power minus 19 joules. So this results 64 joules, students. So as Q is given as 6.25 coulombs. So U and this Q, we know, therefore potential difference V is nothing but 64 by 6.25. That gives 10.24 students, which is the first option. So that is the answer then. Next. The conducting rod of length L rotates with angular speed. Suppose this is the rod, students, in uniform field of B, which is perpendicular to its motion. So like this, it is moving. So this is L by 2 distance, this is L by 2 distance. If total distance is L, because it's saying L is the total length, induced EMF will be developed. Induced EMF, it is nothing but motional EMF, students. Yeah, induced EMF, no? Yes, motional EMF. So I can say that induced EMF is nothing but BLV. Okay, BLV or BV or whatever. So therefore, V is nothing but R omega, students. Okay, V is nothing but R omega. So therefore, R is nothing but L by 2 omega. So let me write here, V is nothing but L omega by 2. Here it is L. So what's the leftover is nothing but BL square omega by 2 is the induced EMF. So is asking for induced EMF. So the option is second one, students, BR square omega by 2. And next, inductor coil is connected to a capacitor and AC source of RMS voltage 8 volt in series. That is RMS current in the circuit is 16 amperes and is in phase with EMF. If this inductor coil is connected to 6 volt DC battery, the magnitude of steady current is. So students, here IRMS given as 16 amperes, students. So IRMS is given as 16 amperes. Okay. Now like this, you can draw the diagram, students. Right. That is the AC source. R current is passing like this. R na seen students, it's capacitance na. Capacitor equal. So this capacitor is not the resistor, LC circuit. So here impedance for this, I'll write for impedance because it's asking for current, steady current. I is equals to V by R. R is nothing but impedance, students, here. It's denoted by Z. So RMS V by R now. V by I, R is nothing but. So RMS values will take. So therefore Z is nothing but. RMS voltage is 8. IRMS is 16. That means 0.5 ohms, students. 1 by 2 means 0.5 ohms. Let it be. Okay. So in the steady state, I dash is nothing but what I can say. I dash is nothing but V by R. Okay, VRMS by Z. We should write. What is VRMS here? VRMS. Okay. That is nothing but a DC only. VRMS is nothing but when this inductor coil is connected to a 6 volt DC battery, I can say VRMS is nothing but VDC, students. That means 6 volts only. So therefore this is 6, students, by Z is nothing but 0.5. That means 12. 12 amperes is the current, students. So therefore second is the correct answer. Second is the right answer for this. Next. Yes. In hydrogen atom, what is given there? Hydrogen atom case. Okay. Hydrogen spectrum, the shortest wavelength in Balmer series is lambda. The shortest wavelength in bracket series will be, this is the question here. All right, see here. So 1 by lambda, we have like R of 1 by N1 square minus 1 by N2 square, students. For shorter wavelength in Balmer series, for shorter wavelength or shortest wavelength in Balmer series, is nothing but N1 is equals to 2, students, and the N2 becomes infinity. Shortest wavelength, right? So, all right. So therefore 1 by lambda is nothing but R of 1 by 2 square minus 1 by infinity square. That means R by 4, students. So R is nothing but here R can be written as 4 by lambda. So let it be. And likewise for shortest wavelength in bracket series, for shortest wavelength in bracket series, it happens for N1 is equals to 4, students, and N2 is equals to infinity again. So therefore 1 by lambda dash and nano, I'm calling this as lambda dash here. So nothing but 1 by this one. So here it's the neo. So therefore R by 16, students, isn't it? R by 16 can be written as 1 by 16. R is nothing but 4 by lambda. So this is 1 by lambda dash. Yes or no? So lambda dash is nothing but 4 lambda. So lambda dash is nothing but 4 lambda. So the second option is correct, students. So next. The RMS speed of a gas molecule at 27 degrees centigrade and at 1 temperature is 100 meters per second. RMS speed of same molecules at 120 degrees centigrade and at 2 temperature will be. Students, V directly proportional to root T, VRMS, right? So therefore, this implies V1 by V2 is nothing but root over 27 plus 273 because temperature must be taken on Kelvin scale. So 127 plus 273 will write. So this gives you 300 by 400 under root. So this V1 is given as V1 given, I think, how much? It's 100, students. So 100 by V2 is like this. So therefore V2 is nothing but 200 by root 3, students. So see the correct option, 200 by root 3. Fourth is the right answer. And next. So here in this case, the parent nucleus, reductive nucleus A converts into reductive nucleus, active nucleus B of decay constant lambda B. Initially, the number of atoms are B0. At any time, Na and B are the number of atoms of nuclei A and B respectively. The maximum value of NB is. So students, here decay constant and number of atoms, it must be constant. N lambda is constant. So since that we are writing like this, NB. So from this, you want for NB, NB is nothing but lambda A NA by lambda B, where this first is the correct answer, students. Next, here it's given electric potential is given there. See for this electric potential 6x minus 8x y square minus 8y plus 6yz minus 4z square. Then electric force is asking. Force is nothing but QE, students. Q given anyhow. V to E to be calculated. E basically minus negative potential gradient, students, minus dV by dt. So therefore, about x direction Ex, if I write minus dV by dx, so it is a partial differentiation, students. Actually, minus dou u by dou x we should write. Sometimes minus dV by dx we are writing. So it means the minus of. So with respect to x only, we have to differentiate, students. So therefore, 6 minus 8y, students, isn't it? 8y square, 8y square, 6 minus 8y square. Likewise, Ey is nothing but minus dv by dy. So minus of y. With respect to y only, we have to differentiate. So therefore, minus 16 xy minus 8 plus 6z, students. Check it. Yes, next. Ez is nothing but minus dv by dz, students. Right? So that means minus of 6y minus 8z. Right? So at origin, I can say that at origin x is equals to y is equals to z, students. That is equals to 0 at origin. At origin is asking. So this implies Ex as minus 6, isn't it? Ey as 8, Az as 0. So therefore, electric field is nothing but root over Ex square plus Ey square plus Ez square, as we know. So that means root over minus 6 whole square plus 8 square plus 0 square. That means it is totally, it is 36 plus 64. Okay, 100 means 10. 10 Newton per Coulomb. So therefore, force F is nothing but Q into E. So that means 2 into 10, that is 20 Newtons is the right answer, friends. As the 24th is the correct answer to this. Right? And next, resistance R is to be measured using meter bridge. Right, a student choose the standard resistance has to be 100 ohm. He finds the null point at L1 is equals to 2.9 centimeters. He is told to attempt to improve the accuracy. Which of the following is useful way? You should measure L1 more. So first of all, Balancing condition is there na for L1. So if you are applying this equation, R by S is which one, which balancing condition, students? Okay, L1 by 100 minus L1, where L1 is nothing but balancing length. This is nothing but balancing length, as you know. So therefore here, if I write for R is nothing but S into L1 by 100 minus L1. 100 minus L1. So that means S is nothing but 100, right? L1, see this, S is 100, right? L1 is 2.9. So 2.9 by 100 minus 2.9, students. So this gives 3 ohms. So the correct answer is third one. You should change S to 3 ohm and repeat the experiment. So that is compulsory in order to get a balanced length. That much balancing length, students. Right? Yes. A traveling harmonic wave on a string is described by this equation given. So is asking the speed of the wave. Wave speed is nothing but, students, omega by k. Right? Your omega is nothing but omega t kx. Generally terms omega t kx. These terms you should remember. So t quotient is omega, x quotient is this one, 0.005, students. So that means 12 by 5 into 10 power plus 3. That means 2.4 into 10 power plus 3. That means 2400 meters per second, students. 2400. So fourth is the right answer, students. Here. Next, a car of mass 1000 kg. A car of mass 1000 kg is moving with a speed 18 km per hour on a smooth road, collides and strikes with a horizontally mounted ideal spring of spring constant. The spring constant given, the speed is given. What's the maximum compression? So maximum compression means X is asking, students. In case of spring, you know that work done during the spring, work done due to the spring is nothing but change in kinetic energy according to work energy theorem. So due to spring means minus kx square, minus half kx square. It's nothing but kinetic energy is okay, according to work energy theorem. Okay, final kinetic energy minus initial kinetic energy we can add. So therefore minus half kx square is equals to here this v is equals to 0 finally. So therefore minus half mu square, students. So from this right, half gets cancelled. So therefore x is nothing but root over m by k into u. So if you're substituting the values, root over m is nothing but 1000 by k is, see the values here according to the given 1000 kg mass, right? Yes. This k value is 6.25 into 10 power 3 into 18 kilometer per hour. So 5 by 18, with that you just multiply. X you are getting as 2 meters, students. So 2 meters is the third option. Next. Yes, you see in the diagram, showing all three rods of equal length L, equal mass and system rotated such that rod B is the axis. What is the moment of inertia of the system? Moment of inertia to be calculated. So along this B, if axis is there, due to the remaining two only, we'll get moment of inertia. Therefore, students, IA plus IC produce the total moment of inertia. So therefore, ml square by 12 plus ml square by 12. Natural axis, students. So this becomes ml square by 6 is the right answer. First is the right answer. Next. Okay. In the following indicate diagram, the ratio of work done in the process 1 to that of process 2. Work done, process 1 to process 2. So process 1 low in process 1, Okay. In process 1. So it should be given like this, students, clockwise, anti-clockwise like that. So if it is in process 1 clockwise, if I take, Clockwise, if I take, it's a positive work, students. That denotes positive work. Positive work. Okay. That is denoting positive work. Clockwise. In process 2, anti-clockwise. So in the positive means work is nothing but pi r square. Right? Pi r square. R only anyhow. So in process 2, anti-clockwise, na? Anti-clock. Anti-clockwise means it's a negative work. So work done is negative. Pi r square. What is r here? 1.5. Isn't it? 1.5 r. So the ratio is asking. So the ratio is pi r square by minus pi 1.53 by 2 means 9 by 4 r square I can write. That is 4 by 9, students. Right? Negative work and a positive work pi r square. That's negative work. But of course, in the ratios, sign need not to be considered. 4 by 9 is the right answer, students. So see the, okay, with the negative sign it is given. Okay, let it be, no problem. With the negative sign also it is given. So this is, fourth is the right answer. Right? And the next is the last one. Mean free path of oxygen molecule at 0 degrees centigrade and pressure P is lambda. That is equals to 9.5 into 10 power minus 8 meters. Keeping temperature constant, pressure is reduced 100 times. Then new mean free path is, mean free path formula we have like this. Mean free path. Lambda is equals to 1 by root over 2 pi and d square, students. Root 2. Root is only for this 2, students. This is 1 by this value we have. This is a formula, mean free path. So where n is nothing but number of molecules per unit volume. So this can be written as P by Boltzmann's constant into temperature, because the lambda, it is related with the n, students, in this. So therefore lambda now it can be written like this. What can we write? Lambda can be written as Boltzmann's constant into temperature by root 2 pi P d square, students. So from this we can say lambda is inversely proportional to P. So therefore now lambda 2 by lambda 1 is nothing but P1 by P2. So that means lambda 1 9.5 into 10 power minus 8 into P1 by P2 is P1 by 100, students. So now altogether P1 gets cancelled here. So therefore 9.5 into 10 power minus 6 okay, meters. See this answer. So third is the right answer, right option. Okay. Likewise, we have all the answers. Okay. Thank you all.